Hello, I'm Max Steiner. You've seen me in such fine, quality, epic chemistry educational videos as What Does Stoichiometry Have to Do with Me? Part 4. And Is Precipitation Only About Rain? Part 5. Okay, today we're going to be looking, this is the second part of looking at a precipitation problem where you're having to use stoichiometry. Okay, so the idea is this, that you have two chemical compounds. You mix them together and probably a precipitate is going to form. Now there are the solubility rules. That would be the subject of another video at another time. But the idea in this case, ladies and gentlemen, we have a problem. Okay? And the question is this: what volume of 0.204 molar HCl is needed to precipitate the silver from 50 milliliters of 0.0500 molar silver nitrate solution? Whew, mouthful. Well, okay, let's take a look at the question. We have to add acid in order to split the silver from the silver nitrate. The silver will connect with the chlorine ion from the HCl acid and settle to the bottom. The question comes down to is, given this concentration of silver nitrate and given this concentration of acid, how much acid are we going to need in order to do this? Well, the first thing that we're going to need to do is we're going to have to look at the equation itself, see if this is balanced or not. Because it's possible that it might be a little complicated, but let's take a look. So when we look at HCl, okay, that's very straightforward. So we know we have an equation of HCl. We know it's an aqueous solution, right? It's an aqueous solution plus, now wait a minute, what is silver nitrate? Well, it's AgNO3. The Ag is the silver. It always has a +1 charge. Okay, and then the NO3 always has a -1 charge. So again, this is another aqueous solution that we have. Okay, and the idea, ladies and gentlemen, is we have AgCl plus HNO3. Now that is going to be in an aqueous format. This is going to be our precipitate, according to the rules of precipitation. This is a metal and a halide that connect together. So this is what our balanced equation looks like. You'd say, well, wait a minute, how do I know that it's balanced? Well, remember your H's, your NO3, remember you can take that as one unit, and you have your AG's. So that's going to take care of everything. You're good to go. Now, the next step. Now that we've balanced it out, and you'd say, but wait a minute, why was that important to balance? I needed to know how many of these HCl's I'm going to need for the AgCl's. For example, here, I need 1 chlorine from the HCl here, right? And I need 1 chlorine for the AgCl. But let's say the HCl, okay, let's say it was Cl2 instead of HCl, for the sake of argument. Then you have double the number of chlorine atoms that you do over here, and we would have to respond differently to it. So let's go through, and what we can do, we can look at our molarity, okay? Now, molarity, remember, it's the concentration. And for molarity, well, the molarity is equal to moles over liters. Now, it could be more or less than 1 mole. It could be more or less than 1 liter. Now, the fact that they gave you milliliters, you have to change it to liters. That's the only way that this is going to work. Okay? Now, in this case here, we have to figure out what volume of this stuff we need, what volume of acid do we need to take out all the silver out of the nitrate and form the AgCl? That's the question. Okay, that's the whole point. But the thing is, how much silver are we going to get? That would be the thing. How many moles of silver? Remember, a mole is a number. A mole is a number. So we need to know how many moles of silver we have. Because once we can figure that out, then we can go back and figure out the HCl. So how do we figure out the moles of silver? Well, remember, we have our molarity formula here. They told us we have 50 milliliters of 0.0500 molar. Well, I know I can't plug that in. For that, I have to change that to liters. How do I change it to liters? Well, how many milliliters are in a liter? 1,000. So it's going to be 50 divided by 1,000. Okay, and what in the world is that going to get us? Okay, well, in this case, to get moles, we have to go molarity multiplied by liters will get us the moles. Notice how I turned around and I took the formula and I wrote that out because I want to know where I'm going with this. So here we are. What's my molarity of the silver nitrate? 0.05. Okay. And that's molar for molarity. And the liters. Here we go. We have to divide by 1,000, right? Another way to do this, that would be quick, is to go and move the decimal 1, 2, 3. 3 places to the left. It's quick, it's easy, and it's the law. So we're going to have, wow, what do you know? 0.05 liters. So we're going to multiply that, and we are going to come out with 0.00025 moles of Ag. That's what we have. Great. Now we know the number of silver atoms we have. How many moles of silver atoms we have. Fantastic. Our next gig. How many moles of chlorine are we going to need to take out all that silver that's in the silver nitrate? See, that's what we have to look at, because the chlorine and the NO3 are going to switch places as a part of this reaction per the solubility rules. You didn't expect that, did you? Okay, so, all right, we have all these moles of silver. How do we know, what do we need to know about the chlorine? Well, if we look here, we can figure out the moles of silver right here, right? They already gave us the information right here. We calculated the moles of silver, so that tells us it's a 1-to-1 ratio, right? For every 1 silver, you need 1 chlorine. Well, I've got 1 here and 1 here. So I don't have to worry about any other numbers in terms of the 2 or whatever. Don't worry about it. Here's your Cl, so that means the number, what does this tell us? What this means, guys, is that the number of moles of chlorine is going to be equal to the number of moles of Ag. That's what we've got right here. Because it's a 1-to-1 ratio. Now, what if there was something like 2 chlorines in there? Then it would be half the number of chlorine moles because it would be a Cl2, right? But for now, this is what we're looking at. The number of moles of Cl must equal the number of moles of Ag. I'm spending the time to explain the theory behind this. Well, how many moles of Ag do I have? 0.00025 moles of Ag. Holy cow. All right. So what do I know? I know that the number of moles of Cl has to equal the number of moles of Ag. Okay? Now, what if? What if? Well, I know in the formula, according to my reaction, 1 HCl, you get 1 AgCl. That's what we have. Okay, and what's that going to equal? Well, if the AgCl moles is already 0.00025 moles of AgCl, we set up the proportion and then we can solve for x. Okay, and that is where you cross, multiply, divide. Okay? So that would mean, let's say if this was an if this was a different ratio, okay, then we would have a different situation. If this was, say, AgCl2, then that would be a 2HCl. It would be a 2-to-1 ratio. But for us now, for this problem, it's 1-to-1. So we have 0.00025 moles of AgCl. That means our x, that means, ladies and gentlemen, we have 0.00025 moles of HCl needed. That's how much we're going to need to go and take out all the silver. Okay, that's the key thing. We need to have the same number of moles of silver and the same number of moles of chlorine. Where are we getting the chlorine from? The HCl. Okay, so now we have the number of moles of chlorine. What else information did they give us? Well, in the problem, they gave us the concentration right here of our HCl, 0.204. So 0.204, okay, we can work with this. We can now work with this. Let's wrap this one up, because if we have 0.204, okay, I'm making sure I have this molarity of HCl, okay. So now we know, again, we need to find out how many milliliters do we actually need of this acid. Okay, that's our target. How many milliliters of acid are we getting? We now have the concentration. We also have the number of moles that we're going to need to cancel out all that silver in the silver nitrate. So, wait, molarity, what are you talking about? Well, remember, molarity is equal to moles over liters. That's the thing. We have the moles, check, we have it right here. We have the molarity, check, we have it right here. Now, we need to find our liters. That's it, that's our target. This is the last step. Woo! Are you excited it's the last step? Are you pumped that this is the last step? Because you should be. After 13 and a half minutes of this, you should be pumped and take it out. And I don't mean on a date. Yeah. All right. So let's go ahead and let's work with the formula here. And we can say, you know what? That liters is going to equal moles over molarity. Just do the algebra thing. And notice, I always, if you guys notice, I always go ahead and I manipulate, move my variables around in my formula. And that way I know. Plus, you get to know. And knowing is half the battle. G.I. Joe! Okay. Let's wrap this up. All right. We have here our molarity. We're going to put this bad boy in red as we go through the number of moles. 0.00025 moles over 0.204 molar. This is it. Our final thing. X will equal 0.0123 liters. Whoops. Let me erase this. 0.123 liters. That would be our answer. Now, of course, the question comes down to is, All right, do we want it in liters or milliliters? It doesn't matter. But in this case here, if you want to change it to liters, remember, milliliters, you can go and move the decimal place to the right 3 spaces or multiply by 1,000, and you're going to get 12.3 milliliters. Yep, that's it. So that's it. I know I spent a little bit longer than I had originally intended in the video, but A, it has been the end of the day for me. I am tired. I'm waiting for my daughter to finish off her volleyball practice, and you know, at this point, I went over in detail, over and over again, the theory as to why are we solving the problem the way that we are. Hey, this is Biff Turkelman signing off. And I do want to give credit to Connell and Donald. Without those 2 snake farmers, life just would not be the same.
Patrick!